So for this video lesson, we're going to be looking at how to work through all these kind of circuit calculations that we've been focusing on. So the first thing I can always do is start with R total. I need to know how much resistance is in the entire circuit. So I'm first going to start with my resistors that are in series, so R1 and R4. Again, they are in series with the battery, and just series overall. So I'm just going to take, I'm going to take 5 plus 3, and then working with the ones that are in parallel up here, I'm going to take 1 over 7 for R2 and 1 over 4 for R3, and that's where I'm going to take their reciprocal, which is going to give me a total resistance of about 10.5 ohms. So put 10.5 ohms right here. So again, taking two that are in series, or any that are in series, add them up, and then taking the reciprocal of any of the parallel branches. Then to get I total, and remember our equation that we were focusing on is Ohm's law, so voltage is always current times resistance. So for I total, I'm going to simply rearrange that for current. So current is equal voltage. In this case, we're going to use the voltage of the battery, which is the 30 volts, and then divided by R total. This is the only time that you're going to use this 30 volts. And then R total, that's the only time we're actually going to use that in a calculation. So we have 30 volts divided by 10.5 ohms, which gives me, gives me a total current, or I total is going to be 2.86 amps, which I can add up here. So 2.86 amps. Now the next thing I'm able to talk about and move from is working with all of the current values here. So first thing we can do is apply our rule that any of the resistors that are in series, again in this case R1 and R5, because all of the current has to go through them, there's no splitting, it's just one pathway, they always have the same current as the total. So in this case I1 would be 2.86 amps, as would I4, because it's also in series with the battery. So now looking at these calculations for I2 and I3, we know that the current, when it gets here, it has to split and move through both of the resistors. Now, it's not going to move through equally, but we know that the total has to be 2.86. So we again can look at kind of our factors that we've talked about. So if I take R2, and I take R3. Remember, we're just going to, for this step, to get these two values, we're just going to add the two resistors together and kind of make a proportionality. So for R2, it's going to be 7/11 of the resistance and 4/11 of the resistance for R3. So again, the 11 comes from adding this 7 and this 4, and then the 7 comes from the resistance, and then the 4 comes from the resistance here. So that's how much of it is going to be resisted, but whatever is left of that fraction, that's how much current is going to get through. So 4/11 for R2, and then R3 is going to have 7/11 of the current. I would then take that and multiply it by I total, which in this case is my 2.86 times 2.86, and what I come up with is this equals 1.04 amps, and here I would get 1.82 amps. So again, which makes sense because I2 has the higher current, so it should have it has the higher resistance, should just have the least amount of current, where I3 has the lower resistance of 4, so it should get more current over here, which it does, and they add up to 2.86. So 2 ways to check your work. These two values need to add up to 2.86 when you do this work down here, and the one with the least amount of resistance should have the higher current, which it does. Then to wrap that up, and I'll just work through one of these. If I'm going to solve for voltage, again, voltage is equal to current time, so I1 times R1 in this case. I'm trying to solve for V1. So 2.86 times 5, which would give me V1, which would be 14.3. So again, that's coming from this value, 2.86 times 5. So I take the current, which I calculated, or we'll use my rule, times the resistance to get the voltage. So voltage is always current times resistance, and the rest would kind of work out the same way to be 7.28, 7.28, and 8.58, respectively. But again, this is the key step right here, getting these two values and using your proportionality down here as part of that.